March 2025, your brain has chemistry hiding in plain sight. You're brewing opioid molecules 33 times stronger than morphine, your body runs a Schedule I psychedelic, and your love hormone skews your loyalty. It feels like calm and craving before you name it, but most of it's unknown. Here are 7 brain chemicals stronger than the pharmacy. Number 1. Natural opioids beyond morphine. The most powerful painkiller in the world was not discovered in a lab, and it was found inside human skulls in 1975. Scientists John Hughes and Hans Kosterlitz were trying to figure out why heroin worked so well. Specifically, they asked what receptors in the brain it was locking onto. What they found stopped them cold. The brain had its own built-in opiates. When they measured potency, your brain's version was 18 to 33 times stronger than morphine per receptor binding. They named it endorphin, endogenous plus morphine smashed into one word. When you discover your body makes something more powerful than a Schedule II narcotic, you name it accordingly. Later work showed synthetic opioids can hit receptor sites inside cells in about 20 seconds. Your own endorphins take over a minute to do the same. That timing gap helps explain why lab opioids can feel so much more addictive even when they're weaker per receptor on paper. Here's how it works. Beta-endorphin releases from the pituitary gland and travels to opioid receptors in the brain and spinal cord. It blocks the neurotransmitter that carries pain signals, then triggers dopamine release. The same system heroin hijacks. Your body uses it for exercise, laughter, sunlight, and surviving emergencies. Soldiers in World War I and World War II routinely sustained severe wounds and kept fighting, reporting they felt nothing until the battle ended. Wartime medical records document this consistently. It's not willpower. It's beta-endorphin flooding opioid receptors faster than the injury signals can compete. Ultramarathon runners describe the later stages of 100-mile races as producing a state they call better than any drug they've ever tried, and that tracks. Their beta-endorphin is binding the same receptors as pharmaceutical opioids at concentrations that would make a pharmacist nervous. One correction, though, the runner's high was credited to endorphins for decades, but a 2021 study engineered mice to lack opioid receptors entirely, and they still got runner's high. Mice lacking cannabinoid receptors never got runner's high, which flags endocannabinoids as the real engine behind that euphoria. We'll unpack that chemistry once we've walked through a molecule you can outlaw on paper but never evict from your own tissue. Number 2. DMT inside your brain. This one requires a moment. There is a compound called N-dimethyltryptamine. It is classified as a Schedule I controlled substance in the United States. No accepted medical use, high potential for abuse, illegal to possess. Indigenous cultures in the Amazon have been consuming it in ayahuasca brews for over 1,000 years, confirmed via residue analysis in archaeological sites. People who take it report entities, alien environments, states of consciousness they describe as more real than ordinary reality. Your brain makes it right now and you cannot stop it. In 2019, researchers published in Scientific Reports in the Nature journal. They documented that the INMT enzyme responsible for synthesizing DMT is present in the human cerebral cortex, the pineal gland, and the choroid plexus. They measured extracellular DMT concentrations in rat cerebral cortex at levels comparable to serotonin and dopamine. It's not a trace contaminant. It's operating at neurotransmitter scale concentrations. The molecule is processed from tryptophan to DMT via a 2-step enzymatic reaction. The same molecule shamans have been consuming to contact the spirit world for a millennium is being biosynthesized in your cerebral cortex. Rick Strassman, a psychiatrist at the University of New Mexico, ran the first U.S. government-approved human DMT study from 1990 to 1995. Subjects received injected DMT in a clinical setting. They reported beings, alien environments, and states of consciousness so vivid they refused to call them hallucinations. More real than real was the phrase that kept appearing. He published his findings in a book called DMT, the Spirit Molecule in 2000, later made into a documentary. The popular theory that the pineal gland floods the brain with DMT during death, explaining near-death experiences, is not confirmed science. A 2019 rat study found elevated brain DMT during cardiac arrest. Whether that elevation causes the NDE phenomenology is undemonstrated. The hypothesis exists, the evidence is suggestive, and the conclusion has not been reached. What has been demonstrated is that DMT activates sigma-1 receptors, which have neuroprotective effects, shielding neurons from hypoxia and stroke damage. The molecule may have a functional biological purpose beyond the experiences that made it famous. It's illegal to possess, and it's impossible to stop your brain from making. If you're finding this interesting, consider subscribing. I drop videos like this regularly, and anyway, back to it. Number 3. Dopamine and prediction error. Here's the real question. Once you understand what it does, you'll never look at your phone the same way. Dopamine is not the pleasure chemical. It's the wanting chemical, the I need to check that again chemical, and the one more chemical. The feeling of satisfaction when you get the reward lands later. The moment you bite into the food, open the gift, finish the achievement. That's largely serotonin and opioids doing the work, while dopamine fires before you actually get the thing you wanted. That changes everything. Here's the mechanism. In 1997, neuroscientist Wolfram Schultz was studying monkey brains. He discovered the dopamine neurons fire not in response to rewards but in response to unexpected rewards. The signal is called prediction error, and dopamine spikes when reality exceeds expectation. It flatlines for fully expected rewards, and it drops below baseline when expected rewards don't arrive. Schultz's discovery unified economics, psychology, and neurobiology in one equation, and neuroscientists still rank it among the most important findings of the 20th century. But here's the darker half. In 2003, a team published a study in Science measuring dopamine neuron firing at 5 probability levels of reward. The sustained dopamine response was highest at exactly 50% probability. Maximum uncertainty, a coin flip, not the most likely reward producing the most dopamine, and the most unpredictable. This is where it gets interesting. They're tuned instead to the exact uncertainty level that produces peak neurochemical craving by design, and that payout spacing is no accident. The house always engineers the gap between wins. Social media timelines, infinite scroll, and notification systems were built on the same principle. That holds whether designers meant to copy casinos or simply optimized for engagement and stumbled onto the same neuroscience. That is the part nobody mentions, and that moment before the content loads is when dopamine fires, not after. Parkinson's disease steadily destroys dopamine-producing neurons buried deep in the substantia nigra. By the time the motor symptoms appear, the tremors, the shuffling gait, the rigidity, 80% of dopamine neurons are already gone. The system has extraordinary built-in neural redundancy, and the silent cumulative damage was massive long before anyone noticed anything was wrong. Number 4, Anandamide, the Bliss molecule. In the early 1990s, scientists had a plant humans had used for thousands of years, cannabis, and they knew what it did, but they didn't know why, specifically which receptors in the human brain it was connecting to. When they found the answer, they discovered something that should not have been there. This is where it gets interesting. You have more of those than opioid receptors and more than dopamine receptors, and the cannabinoid system is vast. The molecule your brain naturally produces to fill those receptors is called anandamide, named from the Sanskrit word for bliss, ananda. Anandamide is your body's built-in cannabis, and it binds the same CB1 and CB2 receptors as THC. It produces well-being, reduced anxiety, altered time perception, and enhanced sensory experience. But the difference between anandamide and THC is not which receptor they hit, it's duration. The difference is staggering. That's why a cannabis high lasts hours and your natural state doesn't. There's a woman named Jo Cameron who found all of this out about herself in her 60s. She'd gone in for a hip replacement and the surgeon was baffled. She needed almost no pain medication and recovered at an unusual rate. Blood tests revealed a rare mutation in a gene called FAAH-OUT plus a variant in the FAAH gene itself. Her FAAH enzyme barely functions, so her anandamide never gets cleared. Jo Cameron has lived her entire life without anxiety and without ordinary fear. She describes childbirth as a tickle, needed no anesthesia for dental work, and healed from wounds faster than expected. She didn't know she was different, she just thought this was what living felt like. Her case was published in the British Journal of Anesthesia in 2019 and enabled researchers to identify the FAAH-OUT gene for the first time. Dark chocolate contains 2 compounds, N-oleolethanolamine and N-linoleoylethanolamine, that inhibit FAAH, the enzyme that destroys your anandamide. This is one validated mechanism by which chocolate improves mood. You're not imagining it, and the chemistry is real even if it's not the mechanism anyone talks about. Your bar also supplies trace anandamide itself, so you are getting 3 related mood compounds at once, not only the pair that blocks FAAH. Number 5, oxytocin and tribal bonds. For 30 years, the story on oxytocin was simple. It's the love hormone. You hug someone and you release oxytocin. You bond with your newborn and you release oxytocin. You make eye contact with a loved one and you release oxytocin. The implication was that more oxytocin meant more love, more connection, more kindness. Then researchers started giving it to people in experiments. In 2009, a study published in Biological Psychiatry gave 56 participants intranasal oxytocin and had them play a competitive game. The oxytocin group showed measurably higher envy when their opponents won more money, and measurably higher schadenfreude, active pleasure at others' misfortune, so when they were ahead. The hormone marketed as the molecule of love was amplifying the least flattering human experiences. A 2010 study found that oxytocin increased favoritism toward in-group members while simultaneously increasing defensive aggression toward out-group members. Researchers called it the tend and defend effect. Multiple groups now use the phrase the dark side of oxytocin. Here's what's happening. Oxytocin doesn't produce love universally. It intensifies whatever social dynamic you're already engaged in. With your tribe, your family, your team, it deepens the bond, and with outsiders, it sharpens the distinction. The same molecule, the same brain, 2 completely different social behaviors depending on who's in the room. MDMA, ecstasy, works primarily by triggering a massive release of the user's own oxytocin combined with a flooding of serotonin. This is why MDMA produces intense feelings of love and connection. It's also why MDMA-assisted psychotherapy, now in FDA clinical trials, has shown promise for PTSD. The therapy uses the drug's oxytocin mechanism to let patients revisit trauma without the amygdala's fear response overwhelming them, and nobody talks about it. Then it was criminalized in 1985. Therapists had briefly used MDMA in couples counseling in the 1970s and early 1980s. The pharmacology was right, but the cultural timing wasn't. Dogs and humans co-evolved an oxytocin loop, and when a human and their dog make eye contact, both experience an oxytocin spike. This is the only non-human species that triggers this response in humans. Testing the same interaction with wolves gets you nothing. The bond is species-specific and tens of thousands of years deep. The correction to love hormone is this: tribal bond chemical. It makes you love your people more and distrust outsiders more simultaneously with the same molecule. Less world peace, more us versus them biochemically enforced. Quick reminder, if you're enjoying this, subscribing helps a ton. Now where were we? Number 6. Adrenaline and the Governor. On April 9, 1982, in Lawrenceville, Georgia, a 135-pound woman named Angela Cavallo lifted a 1964 Chevrolet Impala. Her teenage son Tony had been working underneath the car when it slipped off a jack and pinned him. She heard the crash, ran outside, and lifted the car. Neighbors arrived and replaced the jack while she held the vehicle steady. The incident was documented in news archives and cited in Popular Science. A 1964 Impala weighs 3,500 pounds. Epinephrine doesn't give you strength beyond what the body can physically produce. It does something more precise than that. It removes the brain's self-imposed safety limit on muscle output. Under normal conditions, your brain governs muscle output to 65% of theoretical maximum. Exercise physiologist Tim Noakes at the University of Cape Town called this the central governor style neurological safety mechanism. It prevents you from tearing muscle fibers, snapping tendons, breaking bones with your own contractions because the brain limits output to protect the machinery. In a genuine life or death emergency, epinephrine overrides the governor. The muscles were always capable of the output, but the brain simply wouldn't authorize it. One neurochemical changes the authorization. The mechanism is fast. Resting heart rate climbs from 60 beats per minute to 180 in under 60 seconds. Airways dilate, blood redirects from digestion to muscles, pain signals suppress, and the visual field narrows to the threat. Non-emergency systems, reproduction, immune response, digestion, suspend entirely. Angela Cavallo's case is not unique. Tom Boyle Jr., Tucson, Arizona, 2006, lifted a Chevy Camaro off a cyclist who had been struck 3,000 pounds. Combat medicine records from both world wars document soldiers continuing to fight through wounds that should have been immediately incapacitating. The pain arrived later, though epinephrine suppressed it completely in the moment. The EpiPen prescribed for severe allergies injects the exact same compound your adrenal glands produce. When someone goes into anaphylactic shock, epinephrine is the only first-line treatment. No antihistamine or steroid acts quickly enough. Without it, anaphylaxis is fatal within minutes. The dose in an EpiPen is simply more than the adrenal glands can generate in the seconds available, so they put your own emergency chemical in a pen. It arrives faster than your body can make it on its own. The time distortion during adrenaline states, the sense of time slowing, is also documented and has a mechanism. The amygdala encodes memories more densely during high epinephrine states. More information gets recorded per second. When you replay the memory afterward, the density makes the event seem longer than it was. Slow motion is a memory artifact, not a perceptual one. Number 7. Serotonin beyond the myth. For 30-plus years, the story was straightforward. Depression is caused by low serotonin. That's why antidepressants, SSRIs, work, because they raise serotonin, and about 85 to 90% of the general public still believes this. In 2022, a team led by Joanna Moncrief at University College London published an umbrella review, a systematic review of reviews. It examined every major category of evidence linking serotonin to depression. The 7 categories of inquiry included serotonin levels, serotonin breakdown products, serotonin receptors, genetic studies, and tryptophan depletion experiments. Reviewers tracked every line of that evidence. Their conclusion: no consistent evidence that depression is associated with lowered serotonin activity or concentration, which is not a minor revision. That's a challenge to the foundational claim driving antidepressant prescribing for 3 decades. The chemical imbalance narrative, depression is a brain chemistry deficiency correctable by medication, was not a scientific conclusion. It was, in large part, a pharmaceutical marketing framework. Eli Lilly's Prozac campaign in the late 1980s popularized the serotonin depression equation before it had been established in the research literature. Here's the stranger finding. In secondary analyses from the 2022 review, people taking SSRIs had lower serotonin levels than people who had never taken them. If low serotonin causes depression and SSRIs work by raising serotonin, that result should be impossible. SSRIs do work for patients who respond demonstrably, but why they work may involve completely different mechanisms: anti-inflammatory effects, neuroplasticity via BDNF, expectation effects. The honest answer is we don't fully know. 90 to 95% of all serotonin in the body is produced in the gut, not the brain. The cells producing it are called enterochromaffin cells in the intestinal lining. The gut serotonin and the brain serotonin are chemically identical, but functionally separate. They cannot cross the blood-brain barrier. When someone tells you that eating tryptophan-rich foods will boost your mood by raising brain serotonin, they're describing a biological pathway that doesn't exist. The serotonin made from dietary tryptophan stays in the gut. It regulates intestinal motility and sends signals to the brain via the vagus nerve. Never arriving in the brain is serotonin. Psilocybin, the active compound in magic mushrooms, works by activating the 5-HT2A serotonin receptor, the exact one your serotonin uses. In clinical trials at Johns Hopkins and NYU, terminal cancer patients receiving psilocybin-assisted therapy showed profound reductions in death anxiety. Those gains persisted for months to years after a single session, and the active molecule is a near-perfect structural mimic of your own endogenous neurotransmitter. The through line across all 7 is this: from opioids to serotonin, your brain has been running a pharmaceutical-grade internal operation more sophisticated than anything humans have ever manufactured on an industrial scale. It produces opioids stronger than morphine and cannabinoids indistinguishable in mechanism from cannabis, plus a psychedelic classified as Schedule 1. It runs an emergency override system capable of enabling a 135-pound person to lift a car. It runs a bonding compound that simultaneously intensifies love and aggression depending on who's standing in front of you. The drugs that shaped human culture, painkillers, psychedelics, stimulants, are largely copies of what was already inside. The research literature keeps widening faster than any pharmacy label can summarize, and every year another study rewrites some detail you thought was settled, and the one chemical everyone thought they understood, we're still figuring out what it does. Thanks for watching. If you enjoyed this, subscribe and hit the bell so you don't miss the next one. See you.